Jiaxing Hao. I'm very pleased to be here, and today I'm going to talk about a topic I think we've already talked about quite a bit, which is the OpenO orchestration project. And we refer to it as any service over any network. And the idea is to be able to pull together a lot of the other open source pieces that we've seen to date, and then be able to offer end-to-end service orchestration over a NFV, SDN, and legacy network services as well. So first I want to talk about why open source orchestration is on the agenda, why there's so much interest in this area, why the last 2 or 3 speakers have been talking about this topic. Actually, I think from the initial keynotes, we've talked quite a bit about orchestration, and I want to go into it in a little more detail. Then I want to provide an introduction to the OpenO project, one that I think you're going to hear quite a bit more about because a lot of the activity for OpenO is centered here in China. As a matter of fact, this is my 3rd trip to China in the last, I think, 6 weeks, which is a little bit unusual for me, but I think I'm getting used to it, and I'm happy to be here. And then I want to talk about a new model for open source. I think OpenO is a unique project, not just because it's a global project, not just because there is a significant amount of momentum that's been generated here in China, but also because we're adapting the traditional open source methodology that's been refined over decades to be able to address specific needs of large telecommunications, cable, and other network operators. And then finally, I want to continue the dialogue that actually Colin started in his last talk about what the role of the Linux Foundation is in the actual development of OpenO and open source in general. And a little bit about my background before we get started. I actually just joined the Linux Foundation a couple of months ago, but I feel very comfortable in this community because I've been involved with Dan Pitt and the Open Networking Foundation from the very beginning, way back in 2011. I actually sat on the board of directors for Open Daylight. I represented the 40+ silver members. I've been involved in the SDNFV industry specification group, the Open Platform for NFV, or OPNFV. So I've actually had a lot of experience both in standards, the industry activities, as well as open source. So why open source orchestration and why now? Well, the main reason is because SDN and NFV has gone beyond discussion, it's gone beyond proof of concepts, and it's starting to be an integral element of many of the world's largest operators' plans for their next generation architectures and service delivery platforms. This is, on the left, there's a chart that I borrowed from IHS Infinetics. They're a leading market research and market analyst firm that's global. They look and focus primarily on large operators around the world, and they try to determine what the trends are that these operators are representing. And what we're seeing is just overwhelming support for SDN and NFV, or as Dan would say, SDNFV, which is going to it's going to unfold in many different projects that we're already seeing, and orchestration brings them together, as we'll see in a minute. The other chart that I had is some of the motivations for why we're actually, what are we looking for from SDN and NFV? And it's not surprising. Reducing costs, increasing agility, streamlining operations, all the things that the speakers to date have talked about, so I won't say much more about them. Now, Dan presented a chart earlier where we started with the NFV architectural framework that the ETSI NFV industry group had actually been forging since 2013. And then we also have a slightly different view of the ONF SDN architecture. And open orchestration is the bridge between SDN and NFV. That's one of the key drivers behind the development activity that we have underway, not to mention the architecture activity for OpenO. Another area that I want to talk about is the management and orchestration, NFV Nano. And much of the industry's activities are focused on NFV Nano. And we talk, so this is the Nano, the way it's defined in the SDNFV architecture framework. The idea is to actually look at virtualized network functions. These are the services that are going to be delivered on top of network infrastructure. Those VNFs are going to run on something called the NFV infrastructure. This is the virtualization environment, so you can actually support just a wide range of different virtualized network functions that can be delivered in many different types of service delivery models. NFV Nano to the right talks about things like NFV orchestration, the VNF, or the Virtualized Network Function Manager, which actually gets involved in the life cycle of those VNFs, bringing them up, scaling them, taking them down, and so forth. Not to mention the Virtualized Infrastructure Manager that gets involved, or the VIM, that gets involved in the bringing up the virtual machines and even the containers, ultimately, that these virtualized network functions are going to reside in, at least in the virtualized environment. This is NFV Nano. Now, if we look at the problem that we're trying to solve, though, with end-to-end orchestration, any service over any network, there's a lot of other additional things we're going to have to address. The first one is the BSS, and the OSS for that matter. The existing systems that allow for the interface between operators and the technologies that we've been discussing in SDN and NFV for years now. In addition, we have to talk about SDN. SDN is not part, or at least it's actually a minor part of the NFV architectural framework. But how can we run dynamic services without a dynamic network architecture? We really can't. That's the whole basis behind SDNFV. And then we have to look at the legacy networks. It's not just a greenfield environment where we can just run over SDN. SDN doesn't exist in most parts of the world, or at least if it does, it's a growing but relatively small portion of the existing network installed base of equipment, networks, and services. And then finally, we've got to address the design time. How do we create the services that are going to take advantage of virtualized technologies? We're going to need a design time environment that's going to run in this role. And this is the environment that we're looking for to create an any service over any network orchestration environment that runs end-to-end, ultimately across domains, across SDN, NFV, and existing services. And with that, we introduce the OpenO architecture. And one of the first things that's significant about this diagram, which is actually a preliminary one, since we're in the process of forming OpenO, and I'll talk about the status in just a moment, the OpenO architecture has been created by a group of very dedicated and committed individuals from some of the initial companies who expressed interest in OpenO after the announcement that was made at the Mobile World Congress event in Barcelona back in February of this year. And there was actually some activity leading up to that as well. The idea is that we created an architecture team to be able to address that. Well, most open source projects don't have an architecture team. They start to think about that based on the code contributions, and then they pull it together as they're working through a lot of the problems, and also trying to determine which organizations are going to provide which code pieces. OpenO is a bit different because of the complexity and because of the foresight, and most importantly, because of the operators who were involved, the stakeholders who are actually considering deploying this technology were around the table when we were putting together the functional requirements and the environment that OpenO is going to live in. OpenO is shown in the blue in the middle of the diagram. So if we look at where it sits, we have a portal that sits on top that either allows for the operators that actually work on provisioning and creating new services to be able to interact with the environment, or end users who can actually do the same in the SDN environment, or the SDN and NFV environment. We also have OSS and BSS as shown in the previous chart. We need to be able to integrate with the OSS and VSS, particularly with the VSS, to be able to provide real-world service models versus just lower-level service components that need to be integrated and composed into a broader end-to-end service delivery model. Now, OpenO has three main components. One is called GSO, Global Services Orchestrator. The idea is just what it sounds like. We need a way to provide orchestration across the virtualized services domain that NFV represents and the virtualized network domain that SDN represents, in addition to the legacy network services, which are the majority of connectivity services in most large operators' environments. We then have NFV orchestration, which is going to provide the high-level orchestration that it actually captures management and orchestration, or MANO for NFV, plus some of the other pieces we just mentioned earlier. The SDN orchestration, which is one of the newer pieces, that actually is responsible for sitting on top of the controllers that are shown, that Colin talked about, and Dave Lenrow is going to speak about ONOS, which is one of the other controllers, Open Daylight being the one that Colin just discussed. And then what software-defined networking orchestration, or SDNO, also does is it sits on top of legacy services as well. So you can think of it as bringing together the virtualized services that NFV represents on top of the network connectivity services that SDN provides, not to mention the existing legacy and existing network services. We have a common services block. The idea is to provide reusability. So we intend to be able to take code that needs to move between SDNO and NFVO and even GSO, Global Services Orchestration, and be able to provide it in a way that ensures the maximum reusability and the least amount of new code for doing similar functions. And then we have a series of tools, and then one of the most important areas is our model-driven framework. The idea of being able to create model-driven services that are actually going to flow from the composer who's actually creating those services all the way down into the NFV infrastructure and then into SDN and even into the legacy services as well. Colin mentioned in his previous talk that Open Daylight already provides such a mapping using Yang. We are going to use Tosca for high-level service modeling as well as Yang, and we're going to provide additional mechanisms to be able to provide end-to-end orchestrations and ultimately to actually move between domains, which is one of the most significant challenges that we're going to face over the long term. Now, all of this functionality doesn't exist in day one, but 2 weeks ago we just had a seed code workshop. It was actually hosted by China Mobile here in Beijing, and there we had a number of different organizations present potential contributions to this project, and many of the blocks that are shown on this diagram were covered by those contributions. So OpenO is not just starting with theory, we're starting with a lot of existing code and the potential for a number of projects that not only exist in themselves, but they're going to be integrated together. And we even made tremendous progress at our seed code workshop just a couple of weeks ago to come up with a baseline where most of the organizations, their code was represented in that software architecture baseline that we're going to use when we launch the project, which I'll talk about in a minute. Now, this is the virtualized CP use case. This is very well known with major communications operators. It was one of the initial use cases that the SDNFV group actually defined for network functions virtualization. It's actually one of the use cases that actually brings together SDN and NFV because of the need to be able to instantiate new services that can be deployed on the carrier side, even though they're delivered on the customer side, the end user side. This was actually contributed by some work from some of the major operators here in China. China Mobile, actually, I believe, contributed the slide. My colleague Deng Wei is here in the front row looking on. And that use case is the one that we've been using to help guide our architecture. And that's really significant in that we're not just looking at it from a bottom-up perspective, or in other words, what code do we have or technology we have. We're trying to create the use cases first, and then look at the code we have, and then take a bottom-up, top-down model, or a top-down, bottom-up model, to be able to converge on the functional architecture and then the software architecture that we're going to implement. Now, one of the things about OpenO is that it does actually challenge some of the norms of open source. I mean, I've only been at the Linux Foundation for a couple of months. The Linux Foundation has actually existed over 25 years, and it's very well known, obviously, for its namesake, for Linux, but there's a number of other projects that are actually emerging that are finding themselves in the telecommunication and cable industry and large operators. And the needs of large operators is not necessarily the same as some of the other projects that the Linux Foundation and the open source community in general is supporting. So, for instance, we start with people, and we look at typical open source projects. Most of them are regional. They start with a group of companies or individuals somewhere, and that works in some respects, but ultimately we need to move to a global model. And that global model, similar to what we're dealing with in OpenO, has not only some of the largest companies here in China and operators, but also has organizations in Europe, Israel, and North America, and soon to be an expanding number of companies in other parts of the world as well. We need to create an infrastructure to be able to address that type of diversity on a number of different levels. Then we want to talk about leadership. It's one thing to have an open source project where one source, one company dominates the agenda. This is not necessarily all of them, but certainly many projects start with one company behind them. OpenO, on the other hand, is looking to create a more neutral environment, which is ultimately required to be able to break the vendor lock-in that Colin mentioned earlier, that operators that we've been talking about for 2 or 3 years in that community. We need to be able to get to a multi-source model, not just a one single source model of code, of control, of the direction, the architecture, and so forth. Next, we talk about some of the priorities. Now, open source has traditionally been developer-centric, and there's nothing wrong with that. Developer-centric is why it's been so successful. It hasn't been constrained by a lot of the bureaucracy of, for instance, standards bodies imposed, and other groups imposed, and even companies imposed. Developers have done a magnificent job of taking open source from being something of an anomaly to, as most of the speakers have been talking about today, an integral part of implementing SDNFV. Now, on the other hand, for the operators, for telecommunications, we're going to need a more balanced approach. Developers cannot anticipate the use cases, the priorities, the requirements, the needs to address individual operator environments. If you're China Mobile with 800 million subscribers and a much smaller operator with 20 million subscribers that is deploying in a very regional setting, it's a very different environment. So there's not going to be one model. We need to provide the flexibility but guidance from real-world operators, or else we run the risk of developing a lot of code, and as Paul was talking about earlier, too much code that's not going to be of value. Next, we want to talk about the role of standards. This was brought up a few times today. Standards are really important. However, standards have had a very limited role in open source. But in the telecommunications world, especially on the verge of introducing 5G, we have to be able to address standards. Now, that doesn't mean we have to take a standard and drive the code from that directly, but we have to have standards that can influence, especially lower layer requirements, as we'll see in a moment. And that's why we're looking at providing a new process that Dan Pitt actually showed a little bit earlier, where we actually start to iterate between standards and open source. Not standards drive open source, but open source can drive standards as well. And then finally, it's a question of style. And The open source world, there's a lot of hype, and especially with the large projects. And in what we see in the telecommunications world, things take a long time to unfold. Nothing is going to happen in a single release of open source, I would venture to say, for any complex project. So we need to be a little more understated, which we intend to do. And for OpenO, what we've done is to try to adopt this model. And it wasn't really deliberate. I'm not suggesting that we sat down, created this model, and then somehow we're able to implement that. It's actually the opposite. It's more open source-like. We just started working together, and what I did is just sort of step back and took a few observations, and then I created this diagram. It's very consistent with the open source methodology, where we have contributors, not just companies who sign up to be in the project. We want to know what those companies can do for the project. And then, of course, we can actually address their needs as well. We want to provide a very highly collaborative environment. To give you an idea, we're going to be hosting an introductory meeting for OpenO next week, and it's going to be hosted by not only Huawei, but Huawei and ZTE, and Intel for that matter. The idea is that we don't want to have competitors compete in the open source world. They compete in the marketplace. But in open source, we have to go beyond that. So we have competitors sitting around the table working together extremely well, as we're seeing, and you'll see as more information gets revealed about what we're actually providing. We need diversity in every way. Diversity in open source does not mean multicultural, even though that's important. Diversity means multiple companies are participating on individual major projects to ensure the neutrality that really got this discussion started. We don't want one company to drive the whole thing. We want many companies to participate. We want project proposals to include 3, 4, or 5 company names with operators to ensure that what we're doing is valid and open. And then finally, we want to provide a very respectful environment that there are company interests. There's individual interests. There's an environment that we want to value the contributions of everyone, even though everyone are not going to necessarily be the largest companies in the world, which we have involved in OpenO today. And then finally, I want to talk a little bit about the role of the Linux Foundation. The OpenO project approached the Linux Foundation, I believe it was around the end of last year, and wondered, why would they do that? Why couldn't they just get together with the kind of collaboration, the kind of exceptional people, the kind of mindset that they walked into this project with, which is very different than most areas? Well, here's some of the reasons. One, it's the neutrality, meaning the Linux Foundation doesn't have a vested interest. We're a non-profit open source software foundation. We don't have the same commercial interest that everybody else around the table has. The Linux Foundation exerts best practices in open source that have been refined over many years, 25 years to be exact, with the largest, most successful open source platform at the heart of it, which of course is Linux. We have the infrastructure that allows open source projects to accelerate their activities based on existing processes, existing technologies, existing software platforms that we can use and apply to ramp up the project more quickly. One of the most important areas, as Colin actually, I think, wrapped up his presentation earlier, was the community building. The Linux Foundation is all about community. My job is about community. That's what it's really about at the end of the day. There's millions, literally millions of open source projects in the world today. One data point I saw was 2.5 million in 2014 with a very steep growth rate. So there's millions of projects. How many are going to be successful? It's all about the community in that sense. And then finally, the Linux Foundation has a presence. We need to be able to promote our work because of the crowded landscape, because of the fact there's a lot of misinformation, and especially now that we're seeing open source orchestration unfold without a lot of understanding of what it really is all about. So the Linux Foundation is actually very much involved in the industry. They have a lot of credibility and respect, and what we've done is to be able to leverage that into individual projects. And if you want to get a sense, look at the other side of this diagram that I showed is a little bit different way of looking at what does the world look like in terms of open source for telecommunications and large operators. There's a service layer, and we have OpenO at the top. There's a control layer. There's network control projects. Open Daylight is one. Lenrow is going to talk about ONOS, which is another. There's the infrastructure layer, where we have projects like FDIO, and we have other ones as well. We have reference platforms like SDNFV, which you're also going to hear about shortly. Not to mention other reference implementations ultimately that will be created to be able to address the need to validate how these pieces can be put together into the whole, which is the whole intent of this diagram. And then we even provide a way to promote and communicate what we're doing through some of our events, our outreach, a whole range of different promotional activities. So the Lynch Foundation, in the end, provides the basis to actually allow projects to thrive and to provide the kind of collaborative and rigorous environment that's needed to help avoid some of the problems that we'd otherwise encounter. So with that, I'm going to be here for the next 2 days, and I hope to have an opportunity to meet with you. You know, if we look at some of the, just to summarize about OpenO at least, OpenO is about end-to-end orchestration that runs over NFV, SDN, and existing network services. It's about model-driven automation, which is really the only way to create orchestration. And I think most of the projects are going to address this. It's a modular architecture. So in other words, we don't want to make decisions on which virtualized infrastructure manager does it need to be. Does it have to be OpenStack, for instance? Not in OpenO. OpenO is about the operator making choices that make sense with the technology enabling those decisions. One can select a different controller. One can select different VNF manager opinion. Those are decisions that the operator can make, not OpenO is going to make. And it's backed by the world's largest operators, certainly here in China. It's got a lot of momentum. And it's not just the operators. Large telecommunication industry leaders are also backing the project. Innovative small software companies are involved in the project, not to mention additional operators who are starting to understand the need to be able to build on top of the